Hi guys, this is Marga and this would be the third video that I will be posting on my channel. And in this video, we will learn about the applications of Maxima and Minima. The methods of determining the maximum or minimum value of a function can be applied in a variety of problems in science, engineering, geometry, economics, and other disciplines concerned with maxima and minima. And there is actually no general rule in solving this type of problem. However, you may find the following steps that I will be mentioning in this video helpful in solving our maxima or minima. Now, this would be the steps which we will perform in finding our maxima and minima. So, first, draw or illustrate the figure whenever necessary and denote the variable quantities by x, y, or z or any variable that you want when denoting quantities in the problem. This step would be helpful in solving for geometrical problems that needs to have a representation for us to visualize and understand the problem more. And now for our second step. Identify the quantity to be maximized or minimized and express it in terms of other variable quantities. And if possible, express this quantity in terms of a single variable. And if we're done in our second step, then let's proceed to our third step, which is to differentiate the function in step 2 and equate that to 0. Let's just find the first derivative of the function and set it to 0. And that's all for our third step. And now for our fourth and last step. Solve for the values of the variable and identify if they maximized or minimized. And that would be it. That would be the steps that we will perform in finding our maxima and minima. So now let's proceed to our example. This would be our example. Let's read it first. Find the maximum area of an isosceles triangle with perimeter 18 inches. I think you're already familiar with isosceles triangle since it is already discussed in geometry. But for those who don't know, isosceles triangle is a triangle with two congruent sides. So now let's apply our first step, which is to draw a figure to illustrate or visualize the problem more. So let's consider this figure here as our isosceles triangle that has two congruent sides, and let's consider this as our y and our y here since they are congruent, and here as our x. I think we already visualized our problem. Now let's consider the given values in our problem. So x plus 2y is equals to 18 inches. This would be one of the first thing that we will do when solving this kind of problem, which is generate an equation for us to be able to solve the problem. So again, let's go back to our problem, which is to find the maximum area of an isosceles triangle. So again, how do we find the area of a triangle? So area is equals to 1/2 base times height. So again, guys, let me remind you that this would be one of those formulas that one should always remember, okay? And now let's go back to our figure here. So we can see our base here, but where is our height? So now let's consider our new figure here and locate for the height of our triangle. So this would be our y here. So again, they are both y because they are the congruent side of our triangle. Now let's use an imaginary height here. A height that is perpendicular, which forms a 90 degrees, as you can see there. So this would be our height and our base here, which is our base is already cut equally. So this would be our x and our x here. Let's just use this x to represent our base. So our equation here will definitely be changed because we will consider this new figure. So our x here, it will be now 2x plus 2y is equals to 18. So this will be our new equation that we will consider in solving our problem. We can see here that they are visible by 2, so we will reduce them. So x plus y is equals to 9. Now we have our simplified equation here, but we still don't have the equation for our height. Now let's generate an equation for our height. So let's consider this right triangle here for us to generate the equation of our height by using the Pythagorean theorem. Now again, let's draw our new figure here, the right triangle, h, x, and ry. So by using the principles of the Pythagorean theorem, we will generate our equation here. So x squared plus h squared is equals to y squared. Now what would be our y? Let's go back to our first equation here. We could say that y is equals to 9 minus x. So now we have our y value. We could use this value to solve for y in terms of x. So now let's substitute this. So x squared plus h squared is equals to our y here, 9 minus x squared. Now let's expand. X squared plus h squared is equals to expansion of our y would be 81 minus 18x plus x squared. So let's cancel this out. Now it will be h is equals to square root of 81 minus 18x. So that will be our equation for our h. And now we have our base here. And since in our formula, we have our height already and our base. So let's have the equation for our base. So base is equals to 2x. So now we have the equation for our height and our base, which we need in our formula for finding the area of the triangle. So now let's substitute them. So 1/2 times our base here, which is 2x, and our height, which is square root of 81 minus 18x. So now let's expand. Let's solve them. Area is equals to, wait, let's cancel this out. Area is equals to, again, x square root of 81 minus 18x. So now since we already expressed the quantity in terms of a single variable, we can now proceed to our third step, which is differentiate the function. So now let's differentiate the area. dA over dx is equals to, now we could use the product rule here. Now let's copy x here and then differentiate this one. We could use the square root rule here. Now it will be the derivative of the inside here, negative 18 all over 2, and then copy square root of 81 minus 18x plus, now copy this one, square root of 81 minus 18x And then let's derive x, which is 1. So now after we differentiate the function, we will equate it to 0. But let's first simplify this one here. This will be negative 9 here. So now this will be negative 9x all over square root of 81 minus 18x plus, it's just square root of 81 minus 18x is equals to 0. So to eliminate the fraction here, we will multiply it to square root of 81 minus 18x. Now it will be negative 9x plus, since we will multiply this one here, the square root will be cancelled out, so it will just be 81 minus 18x, and it is equal to 0. Now let's add them. It will be negative 27x is equals to, move it there, negative 81, divide both sides by negative 27. So our x will be 3. Now we already have the value of our x, which is 3. So now let's substitute the x here to get the value of our height and our base to solve for our maximum area. So again, our x is equals to 3. Now let's solve for the value of our base. Base is equals to 2x. Now let's substitute the value of x, 2 times 3. So our base is equals to 6. So now for our the value of our height. So let's copy this one here. Okay, square root of 81 minus 18x. Then let's substitute the value of x. Square root of 81 minus 18 times the value of our x, 3. So square root of 81 minus 18 times 3, 54. So square root of 81 minus 54 is equals to square root of 27. And we could say that 27 is a product of 9 times 3. So our height here will be 3 square root of 3. So now that we have our values of base here and our height, we can now substitute it to get the maximum area of our isosceles triangle with perimeter of 18 inches. So now let's substitute the values. So 1/2 times base, which is 6, times our height, 3 square root of 3. Now let's solve for our area. So let's cancel this out. Now our area will be 9 square root of 3 inches squared. So this would be the answer to our problem, which is to find the maximum area of our isosceles triangle with perimeter of 18 inches. So area is equal to 9 square root of 3 inches squared. And that would be it. We draw our figure here to visualize our problem, and then we had our equation here. We use the Pythagorean theorem to get our second equation, and then we used our first equation here to solve for y in terms of x to get the equation for our height and our base. So we did the derivation. Since we already expressed the quantity in terms of only one single variable, so we derive it by using the product rule and equate it to 0. And now we solve for our x, And our x is equal to 3. This one here. And since we have our x here, we did we substituted to get our base and our height. And then substitute the values of our base and height to get the maximum area of our isosceles triangle with perimeter of 18 inches. So 9 square root of 3 inches squared is the answer to our problem. So that's it. This is Marga, and if you find this video helpful, please like and comment down below, and please do subscribe and check out for my next video. Adios!